All right, so 7.3, this is called special exponential functions. And today we're going to learn about a new, well, maybe not new, but a button on your calculator that you probably haven't used much before. Okay, this is the E button, and it is the natural base of a function. Okay, so there's a couple places where you're going to see E on your calculator. The one we're going to be using the most is the one that says E to the X. So I want you to go ahead and find that now. Okay, and what we're going to do is we're going to see what E to the power of 1 is. Okay, so E to the power of 1. Okay, so that is a very special value. It's an irrational number. You may also notice that there's an E function here. So if you do second and then that E, they are the same thing. So E to the first and E are going to be the same value. We're going to be using E to the X because we're going to be plugging in different values for each one. So the number E, you can kind of think of it like pi. You know how pi represents a certain value? E represents a certain value. Okay, so it is approximately 2.71828. Okay, so like pi, E is an irrational number. Remember, if a number is irrational, it's a never-ending decimal that does not repeat. Okay, so E is an irrational number, which means it's a never-ending decimal that does not repeat. Okay, and in this case, the value of E can be approximated from a special formula okay, 1 plus 1 over n to the power of n. And this number is what happens when the value of n approaches infinity. Okay, that's where this value comes from. Do you guys know where the approximation of pi comes from? I wasn't sure if you guys did any explorations with circles, the radius, related to the circumference. Yeah, it is a radian value. I wasn't sure when you guys studied with circles if you guys ever did like a exploration between the diameter of the circles and their circumference, and the relationship is pi. Anyway, so this is how you could approximate that. This is where it comes from. Okay, we have this number and we're going to be using it. So it's a base, and therefore that means it is always going to have an exponent. So it can't just be e to nothing. At the very least, it's e to the first. Okay, sometimes you will see that it is referred to as the exponential function. Okay, and then many application formulas have this constant e. So we're going to be talking about those as well. If you have done interest before, you may have done the PERT formula. That's something that we're going to look at today. So the parent function is f of x equals e to the power of x. And we're going to graph this. Okay, so we're going to just create a little xy table here. And we're going to plug in -2, -1, 0, and 1. Okay, so you can use your table. I'm also just going to show you how to evaluate with the values of e. So you can do e to the -2. Okay, that's what you're plugging in here. to 3 decimal places, e to the -1. Round that up. And then e to the 0 is just what? 1. Anything to the 0 power is 1. So that property still applies. And we know e to the first, we explored that today, is 2.718. Okay, so when we are putting that on our graph, just remember what your y-intercept's going to be. So it's 0, 1, that's your y-intercept. Put my y-intercept there. And then this is going to follow an exponential pattern. Okay, we aren't going to plot any specific points on this one. We will do that today. We'll plot specific points with different functions. And then just like we did with our other exponential functions, you are going to have an asymptote that is horizontal. Okay, so this is going to be y equals 0. And it is an exponential function, which means your domain is all real numbers. Okay, so x such that x is an element in the real number set. Okay, the range works very similar to how we did our exponential functions. They're going to be greater than the asymptote, or they are going to be less than the asymptote, depending on what your graph looks like. Our parent function has all of those values above. Okay, now before we get into the graphing of these functions and the applications, we're first going to do some simplifying. In example 1, we're going to do without a calculator. Okay, so when you simplify the expression, you are going to use the same base properties. Okay, so these are your algebraic properties. We worked on some of those in chapter 6 as well. Okay, so if you are multiplying values with the same base, what do we do with the exponents? Add them. Yeah. Okay, so if you have the same base and they're being multiplied, you add the exponents. So this is 4 plus 3 plus, what's the exponent here? 1. Great. Okay, so then if that's 8, your final answer would be e to the 8th power. Okay, and then for this one, if you have a power to a power, you want to multiply, but we also have to distribute the exponent. Okay, so you have -6 and you have e to the 2x. So you have to do -6 squared times e to the 2x squared. Once you have that, then you can multiply. Okay, so if you have e 2x to the second, that's going to be e to the 4x. -6 squared is going to be 36. So this is your final answer. Okay, so you have to make sure you apply the 2 to the number, okay, and to your base e. All right, based on what we did for A and B, I want you to see if you can do part C. Okay, this is something that we did in chapter 7 with the same bases. Okay, so if you aren't sure what to do with the variables, let's at least take care of those numbers there. Okay, because just like we did before, if you have the number and it's to the power 2, you're going to square it. So what should I do to those two numbers? We're not going to do that. So you would square root it if it was inside the parentheses, but the exponents in this case, this is only on the e, not on the 60. If it was in parentheses, then you would have to do that. So what else can we do? Let's think about it. Yep, you can divide. So if we divide the numbers 60 by 12, okay, yep, it's going to be 5. And then if you're dividing, what is the rule of your bases? If you have the same base in its division, what do you do with those exponents? Subtract. Yep. So this is e to the power of 1/6 minus 1/2. Okay, so it's 5e to the, and then we're going to have to subtract those. So go ahead, get a common denominator, find the exponent, and then we're going to talk about it. Okay, so write down what that's going to be. Okay, and then Abby, when you subtracted those, let me know what you got. It should be negative, not 2, we say 2/3. It would be negative 2 over. So if you multiply this by, then you have negative 2, but it's going to be over what? 6. Yep. So then this is going to reduce to negative 1/3. Okay. Now remember, we don't want to leave that as a positive. So as a negative. So we have to make it positive. So in order to do that, that means on your fraction, e to the 1/3 would go in the denominator. Where would the 5 go? On top. So the 5 does not have a negative exponent, so it is going to go in the numerator. Okay, the exponent is only on the e, which is why the e is going in the denominator. Okay, and you can just leave it like that. You don't have to rationalize. Okay, you can leave it as the 1/3. All right, and then the next thing we're going to talk about is continuously compounded interest. This is one of the applications of the value of e. So we have a special formula. Hello. Yes, I will. Yeah, fine. Okay, and then your equation is a equals PE to the RT. Okay, and I want you to write down what the P is going to represent, the R and the T. Okay, that's based on what we did the other day. The P, the E, the R, and the T. All right, Alina, what's that T mean? Yes. Ian, what's that R mean? Great. Elijah, what's that P mean? Which is, but why is it P? Yeah. Okay, so the principal amount is your initial amount, and then when you're dealing with money, they just call it the principal amount. Okay, and just like before, when you're doing the rate, it's going to be written as a decimal. Okay, so your rate is a percent as Okay, so Latoya invested $500 in an account that grows continuously at an annual rate of 5.25%. Okay, so one strategy that we used earlier this week is anytime you see a value that you know you're going to plug into your equation, we want to highlight that, and we're going to put what we're going to plug it in for. So the principal is 500. Okay, your rate, let's go ahead and move that 2 decimal places. So 0.0525. Okay, it's 2 decimal places because you're dividing by 100. And then for part A, it says to write a function. So you have got to write a function in this form. You need to have a y equals or an a equals in your function. Okay, you have to have variables in there. The reason why we didn't write what e was equal to is because e is the exponential function, so you aren't going to be plugging anything in for e. And when you're writing a function, it says a is the value of Latoya's investment after t years. So t years in a, those are going to be the 2 variables that you are going to see. Okay, so if you haven't already, I want you to write that function for part A. So based on those values that you have, we're going to write a function for part A. Okay, and then Elliot, will you tell me what you got for that one? No, for A. No, you roll A equals, right? Yeah. Okay, so A equals
500.
Okay, and then, so again, I just want you to make sure that you have the A equals, okay, that is going to be part of it. Okay, and then for part B, it's saying what is her investment after 40 years? Okay, so Nolan, how are we going to tackle that question? What are we going to do? Yeah, we're just going to put 40 in for T, so we're going to do A equals 500E 0.0525 40. Okay, now this is money. So whenever you're dealing with money, you are always going to round to the nearest what? Yep, the nearest cent. So 2 decimal places, the nearest hundred. Okay, so 500E 0.0525 times 40. So we have $4,083, and it's 0.084. So it becomes 8 cents. Okay, is your final answer. All right, any questions on page 1? All right, then for page 2, we are going to be graphing our functions and then determine the domain and the range. Okay, and we're going to make a table with 5 values. Okay, and you can have more, it just needs to be at least 5. Okay, so we're going to use that E button. I want you to plug that in to your Y equals. So plug that in, and then you guys are going to make the Y equals. All right, so you have e to the power of x minus 2 plus 1. Okay, if you're graphing this, you might want to go back to your standard window. Mine is still in what we were doing the other day, so you can just go to Zoom 6. Okay, and you can see your graph there. All right, so then we're going to make a table. Okay, now when you are making your table, I'm going to give you a little hint to find the center of your graph. Okay, to find the center, you just have to set the exponent equal to 0 and solve it. Okay, so this can help you with how to set up your table. What are some good values to use? So if you look at your exponent on E, okay, we have x minus 2 as our exponent. So if we set that equal to 0, x would be equal to 2, and then we can put that in the center of our graph, of our table. Okay, and then, so my table set is still going by 5, so we can just change that. You can start at 0, just go back by 1s. Okay, so if I have 2, then I would go 2 to the left, 2 to the right. And it's fine if you just want to round to the nearest 100. Okay, so now you're going to create your grid here. Okay. Really, all of mine are positive, so. Okay, and I can go by 1s here. Okay, so at 0, I'm at 1.1. At 1, I'm at 1.4. 2, I'm at 2. 3, I'm at 3.7. 4, I'm at 8.4. Yeah, 5, I'm at 21, so it's going to be pretty steep from there. Okay, and then you don't just want to leave it like this. Okay, so you don't have to put more on your table, but look and see what's happening. You're getting closer and closer to what value? 1. Okay, so these are getting closer and closer to 1 here. So we are going to extend that. We're going to put the arrow on it. Okay, so when you're doing a test, you can't just stop it there. Okay, and then you are also going to want to put the asymptote on there. So your asymptote is 1, because that's what it is getting closer and closer to. Okay, that is something that on your test it'll say that you have to include that. So you will want to practice that. Okay, your domain is all real numbers. your asymptote is at y equals 1, that directly relates to the range. It's either going to be above it or below it. So this has all the points above, so it'll be y is greater than 1. Okay, and once you finish that, I want you to go ahead and start part B. So find where the center of your table is going to be. And then let's plug that into our y equal. And then see if you guys can come up with your table for this one. Remember that to find the center, you just set the exponent equal to 0. So do that for this case so you know where that center of the graph is going to be. Okay, so what should go in the center of your table for this? 0. Okay, so if it's just x equals 0, that's going to go in the center. And then let's see what happens on either side. Okay, so again, you only have to write down your 5 points, but you might want more than that in order to graph. Okay, so you can use your table. Do you know by looking at the equation what your asymptote is going to be? 2. Yep, because you have this 2 on the outside there. You can also notice that on your graph. All these values are getting closer and closer to 2. So as you keep going more negative, you're going to see you're getting closer and closer to 2. Now it looks like it reaches 2 exactly, but if you arrow over there, do you see how it's not 2 exactly? That's why you can't have the equal to in your range, okay? So that number is really small, and your calculator only has so much space here, so it will do the rounding, okay? So it will round that in your table. Okay, so then you guys can make the scale that you would like here. We do have negatives on this one and positives. And then I decided to spread mine out a little bit. Like I went by halves because I had this negative 0.7. So I was thinking if I made this my 2, this could be 1.5, this could be 1. 1.5, 2, a half. And then this would be 0. Oops, you don't have to do it like that. It's my x. So a half, negative 1, a half, negative 2, negative 3, negative 4, okay, and then I just went by ones here. Okay, and we know this is going to be y equals 2. So make sure you put your asymptote on there, and we're going to label that. And then go back and fill in the range if you haven't done that already. And then keep in mind this is going to be going along your asymptote there. So you want your arrows on both. If you wanted, you can extend this even if your whole way there. Okay, so this time the y is going to be less than your value, so it's going to be y is a less than 2. Okay, so that is very similar to graphing the exponential functions we already did. It's just we have decimals and we're working with the value of e. Okay, and then the last thing we're going to do is a skill we practiced really early on in the year, okay, where we're using a graphing calculator to solve a system of equations. Okay, so we're going to use a graphing calculator to solve by creating a system, okay, and we are going to round to the nearest hundredth if we need to. Okay, so the first thing we're going to do is write a system. We're going to graph it on the calculator, and then we're going to find the intersection. Now, when you are finding the intersection, you are still solving for x. So you need to find what x equals. Okay, your system of equations is just going to be based on each side of your equation. So in y1, we're going to put -6. In y2, we're going to put -1.5 e to the x minus 3. Okay, so that is step 1. We're going to graph that on our calculator. So we're going to go back to our y equals. Going to put in -6 here. And it really doesn't matter which one you put as y1, y2. Okay, and I want you to go ahead and graph. And remember, if you graph and you don't see both lines, then you're going to have to adjust your window. Okay, if you can see both lines and where they intersect, okay, then you can use your intersect feature. All right, so this one you should be able to see it in that standard 10 by 10 window. Okay, so we just used the intersect feature. Do we need another tutorial or are we good? Okay, so we're going to go to second calc. The intersect, it's going to ask you first curve, second curve. As long as you get it as close to that point as you can, okay, it will give you the correct value. So you have x equals 4.386 ... To round correctly, you just look at that number behind it. So 4.39 is your final answer. All right, go ahead and do part B. I'm going to come around and check your part B. All right, so when you do the intersection, hey, some of you are getting the what did you guys get? Tell me. X equals 0. Some of you got that exactly. Okay, and then some of you might get something that rounds to 0. If you get something like this, negative 8e to the negative 16. Remember that means that you move the decimal 16 places. So you'd have a decimal, 15 zeros, and then the 8. So that would round to 0. Okay, sometimes your calculator does that. Okay, so remember that if you get something with an E in it, okay, a lot of times that is going to be rounded to 0. Okay,